About the effects of wire 1 and wire 2. So wire 1 is a wire which is carrying current, so it's creating a magnetic field, and a magnetic field that exists right here. So let's see if we can figure out that magnetic field. Here's wire 1. We'll just draw in a new picture down here so the top one doesn't get too messy. Here's wire 1. It carries current I. What is the magnetic field around this wire? It makes big circles around the wire, so it comes like this. Big circles. What is the direction of the circles? What's the direction of the field? It's tangent to the circle at any point with the orientation given by my fingers. So tangent to the circle would also be perpendicular to the radius. So a tangent to the circle with a line pointing in the direction of my fingers here would have to look like this. So here's magnetic field B1. Let's see if we can find the magnitude of magnetic field B1. So what we know is that B1 equals mu naught times I1 over 2 pi times R. B1 is a vector, so it has a direction. So let's put the direction on there. If we draw a horizontal line here, and we draw a line going on from this edge of the triangle here, we know that this is an equilateral triangle, so that's 60 degrees. So this is 60 degrees, so this has to be 30 degrees because these two lines have to be perpendicular. So B1 is equal to mu naught times I over 2 pi r at 30 degrees below x. So now what's the effect of B1? Because we have a current carrying wire here at the top of this triangle, and it's got a current that points out of the page. So this current carrying wire must feel a force due to B1. So it definitely is going to feel a force. Let's see what we can figure out about that force. So the force on that wire, let's get the direction first, because we know that magnetic force due to wire 1 equals I3 times L cross B. And that's the field made by wire 1. So we point our thumb in the direction of the current, which is out of the page. And I'm just going to turn the page here. It's getting a little hard to do. So my thumb goes with the current, my index finger goes with B, and my force is perpendicular to both of them. So my force is coming up this way. So there's my magnetic force comes up this way. So there's F1. And then the magnitude of F1 is equal to I3 times the length of the wire times magnetic field B1, mu naught, so I3 has a magnitude of current I3, which eventually we're trying to figure out, mu naught times I1 we just called I, over 2 pi r. It is a vector and it's 60 degrees above x. So there's our force on this wire due to this magnetic field created by this wire. So let's redraw that on our picture. Up here we knew that the net magnetic force was up. We're getting a little more into the details. So the force due to this wire is up at a 60-degree angle. So let's draw that guy in there. There's F1. All right, next let's move on and we'll find the magnetic field due to the second wire.